Okay, so as I was saying, I was going through the sexual reproduction with you guys. So I was saying that it involves two strains, right? Positive and negative strain, or the plus and minus strain. And these strains would lie side by side and develop a short stem, right? Which would grow towards each other, which we are calling the progametangium. Now, this progametangium would meet up and then form a cross wall, right? And then this cross wall, the tips of these progametangium cut off, and then the wall dissolves and then forms the gametangium. Now, the gametangium, there's exchange of nuclear material, cellular stuff, like fertilization, sort of, and then produces the zygospore. Then, when the zygospore is ready to develop into a new strain of hyphae, which will then move on to the mycelium, what happens is the suspensors will dry, shrink off, and then you have a free zygospore, which would remain dormant, awaiting further instructions, to develop into a new hyphae. So when these instructions come, what happens is it joins or forms on a new suitable substrate, right? And then this substrate provides the necessary amount of water and nutrients. So it absorbs the water, bursts open, and releases the new hyphae. Then the new hyphae will develop rhizoids, which will anchor it to the substrate. And then there will be exchange of material as well, which is the food substances. Because these organisms are saprophytic, when they land on substrates, the only thing they do is they are getting nutrients from them. So they release enzymes into the substrate. If it's carbohydrates, it breaks them down into their various monosaccharides. And then these monosaccharides are absorbed into the hyphae. And it is used for growth and metabolic activities. So yes, that's the sexual reproduction. So now, these are some economic importances of rhizopus. So they are mostly used in alcoholic beverages, right? Used in the production of cortisone, lactic acid, fumaric acid, etc. Right? So they are mostly used in the production of these alcohols and then acids as well. And then they are used for bioabsorption or bioresorption of heavy metals in wastewater. Because when they land on suitable substrates, the rhizomes are able to tap the nutrients out into the hyphae. You can use this as a means of taking some heavy metals out of water, or you can use this to, let's say, absorb some nutrients out of water or certain unwanted substances which would be necessary or needed for the rhizopus. You can use the rhizopus to tap out these substances out of the water that you need. So yes, that's all about the rhizopus that you need. It's a very simple organism. And the most of the things you need to know, I've mentioned before, the fact that it's a saprophyte, it's a parasitic fungi, it's cynocytic. Its classification, as you can see here, you can take screenshots or write them down. This is its classification, right from the kingdom to the genus. There are a lot of species, obviously. So it depends on what type of rhizopus you want to take a look at, then you can have the species. So I said it's a fluffy mass, but under critical look with the microscope, it's string-like, there are string-like structures, right? And these string-like structures are known as the hyphae. And a mass or a ball of hyphae is what we are calling the mycelium. So those white substances you see on spoiling carbohydrate foods are actually mycelium. They look like cotton or they are foamy in nature. Yes, those are the mycelium. And as I said, you can have the hyphae in three forms. You can have the horizontal form, stolon, the root-like form, rhizoids, and then the one that arises from a stolon and rhizoid connection, this part, or the vertical part. Let me see. You can call that the sporangiophore. Now, the tip of the sporangiophore is the columella, and that structure has the sporangia or sporangium, which contains spores. And these spores aid in asexual reproduction. So at maturity, the sporangia would break open, right, releasing these spores, which will be transported by wind, land on a suitable substrate, develop rhizoids and hyphae. So the rhizoids penetrate into the substrate, tapping nutrients, and then develops into a hyphae. The hyphae undergoes development as well and generates the mycelium. Okay. I've talked about the nutrition, rhizoids, anchorage. The same rhizoids will release enzymes into the substrate, break down the substrate into its simplest form so that it can be easily absorbed. And as I said, organisms that undergo this are saprophytes or saprophytic in nature. Reproduction, I've talked about the sexual and the asexual reproduction. So basically, everything I've mentioned here is what is important. Take note of the strains, the positive plus strain and minus strain, and all the stages, especially in the sexual reproduction. It's mostly asked a lot. And then learn how to draw the rhizopus, and you should be good. Okay, so I'll be ending the class here. If you have any questions, please let me know. You can type it in the comment section or you can unmute and tell me. I'll answer. Anyway. Anyone with a question, please? Okay, so if we do not have any questions, then I'll be ending the class here. Thank you so much for joining, and then I'll see you in the next class.